Greetings. Let's begin, as usual, by putting our name and a number at the top of the paper. Date is optional, but you know what? Sometimes I forget what year it is, so you might as well put something in there, don't you think? In some one-on-one observations I made with students today, I think it's worth noting something. If we were going to take two, maybe not too bad numbers to multiply, like a 6 times a 4. If you skip count by 6s 4 times, you get what? It'd be 6, 12, 18, 24. Okay? So 24 is the answer to that problem. If I want to use the divide symbol to rewrite this problem, then I know that I must take the larger number, the largest number, 24, and put it at the beginning. Okay? If I divide it by 4, then I get 6. Or I could maybe divide 24 by 6, and what do I get? 4. These two switch. Kind of like with the commutative property, right? 6 times 4 is 24, or I could say 4 times 6 is 24. You get the same answer, no matter what. But here, when we're talking about divide, the largest number is important, okay, if we're going to rearrange from a multiplication standpoint, okay? Keep that in your brain. If we need that going forward, that's a little helpful tool just to remember. Josie was planning a party. She drew a sketch of how she wanted to set up the chairs and tables. Which equation best represents the number of chairs she sketched? So we want the number of chairs. What are chairs in this diagram? Well, a line represents one chair, and a square represents a table. So how many tables do we have? 1, 2, 3, 4, 5, 6. We have 6 tables. And then, it looks like each table has 4 chairs. 4 chairs. I'm going to say per table. Okay? So, one of these represents the number. I could count by 4s. 4, 8, 12, 16, 20, 24, and get to 24. Or I could maybe do some multiplication here, but if you take a look at this, we're not going to add 4 plus 6. Okay? I don't know where the number 42 came from, or the 4. Well, the 4 maybe came from 4 people sitting at a table, but we're not subtracting, okay? We do want multiplication. I'm going to let you choose which one of those is the correct representation. One number should represent tables, the other should represent chairs, okay? Chairs at each table, okay? By the way, you can pause this whenever you want to answer these questions. There were 24 kids at Josie's party, including her. So there's not 25 total. If she's there too, there are 24 kids, and each of them ate 3 pieces of pizza. Each of the 24 kids had 3 pieces of pizza. Which representation shows how many pieces of pizza everybody ate in all? Okay, so every one of them ate 3 pieces. Okay, should be a pretty big number, right? 24 plus 3, no. Because all we did was take 24 kids and add 3 more kids. That doesn't work. 24 kids minus 3 kids? No, that's not what we're talking about. It leaves me with these choices. I can divide 24 by 3 and get 8. Or I can take 24 times 3 and get a larger number. Do you remember how to do this? To do the stacks? 3 times 4 is 12. Carry the 1. 3 times 2 is 6. Plus 1 is 7. So the answer to this equation is 72. One of these tells you how many pieces they ate in all. Okay? But if one person ate 3, 24 would be quite a bit more than 3. Don't you think? I don't want to tell you the answer to that one, but I'm going to let you take a guess at it, take a stab at it. At the end of the party, the kids broke open the piñata. When they scrambled for the candy, Gabe got 5 pieces. Maria got 3 times as many pieces. Which of the numbers described below shows how many pieces of candy Maria got? Well, it says Maria got 3 times as many pieces as Gabe. Are we going to do the sum of 5 and 3? Sum would be plus. Are we going to do the product of 5 and 3? That would be times. The difference between 5 and 3, that would be minus. The quotient of 5 and 3, that would be dividing. It says 3 times as many pieces. So I'm going to let you make that choice on your own, okay? 3 times as many pieces. Use those words to help you figure it out. Josie has 5 gallons of fruit punch. This table shows how many cups there are in different numbers of gallons. 1 gallon has 16 cups, 2 has 32, 3 has 48. Okay? What is one way to figure out how many cups of punch that is? So we have 5 gallons. Looks like they have a ratio table, and each time they go down, they add 16. Okay? And then they add another 16 for every one that they go down. 1, 2, 3, 4, 5. Now, what is one way to figure out how many? We could add 16 to 5. Well, we're adding 16 to these numbers here. That's not 5. Multiply 5 by 16. Well, let's see if that works. 1 times 16 is 16. 2 times 16 is 32. That's true. 3 times 16 is 48. So maybe taking 5 times 16 could work. Dividing 16 by 5. Ooh. Well, if we took the number 16 and we divided it into 5-ish pieces, man, that's going to be a little on the awkward side because we won't have an even number. So I don't like that. And subtraction, subtract 5 from 16, we get 11. But where does that number come from? 1 times 16 is 1. 2 times 16 is 32. 3 gallons times 16 is 48. I think we're going to want to multiply. Okay? That ratio table can be set up a couple different ways. You can think of it as adding downward, or if you want to find a number way down, right? In our ratio table, if we have 1 is 16 and 2 is 32, and then they say, how many is in 100 gallons? Well, you don't want to add 16 100 times, right? Ooh, did you hear what I said? 100 times. Oh, so I could just take 100 times 16, and I know that there would be 1,600 cups in 100 gallons of juice or punch or whatever it said on that problem, okay? So that times is really important. Draw a line to match each story problem below to the equation that best shows how to solve the problem. Then complete each equation. You can use the base 10 grid paper on the next page if you like. So if you want to, you can draw these bad boys out. And maybe I'll do one of them with you, okay? Josie's mom bought 4 packages of mini candy bars to put in the piñata. There were 28 in each package. So how many mini candy bars were there in all? So we had, ooh, are there even enough on here? So we had 1, 2, 3, 4 packages, and each one had 28 in it. Remember, we used the solid lines for 10, 20, 1, 2, 3, 4, 5, 6, 7, 8. So that's 28. This is 4, okay? And if you wanted to, you could absolutely do the shading. I'm going to just because. So I like filling in solid lines with the 10s. Ooh, that's kind of a scratchy sound. And then I do dots. 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Make sure you do dots for the units, okay? And then what was the question? What did it actually ask? By the way, pause this video anytime you need to. How many mini candy bars were there in all? 4 packages, 28 in each. We're going to multiply 4 times 28. Now we did some of the work already. 4 times 10 is 40. 4 times 10 is 40 again. 4 times 8 is 24. It's 8, 16, 24, 32. Excuse me. I need to count better. 40 plus 40 is 80. So if I combine those, I get 80. Plus another 32. That's going to be what? 112 pieces. Okay? P-I-E-C-E-S. There we go. So as I go back into here, I have to figure out which one of those was represented. And we said 28 times 4 was, what did we say? 112? 112. And I'm going to draw from A down there. Okay, so we're going to connect the two ideas. Now, you are going to do the same thing with B, C, and D, and then connect them wherever they need to go to the other 4 equations. I'd like to turn you loose and give you an opportunity to do these on your own as much as possible. Some of these, though, we can figure out together. 28 plus 4 is 32, right? 28 minus 4 is 24. 28 divided by 4. Do you remember how we said this? This would be the same as this number times 4 equals 28. And then we just switch them, right? What times 4 is 24? Is it 5? 5, 10, 15, 20? No. Is it 6? 6, 12, 18, 24? No. Is it 7? 7, 14, 21, 28? Yes, it is 7. So 28, if you divide it by 4, you get 7. Okay? Now, we've done the answers. You have to figure out which of these problems are going to help you get there. Josie got 28 napkins out of the package, but then realized that she could put 4 of them away. So she got 28 out of the package, but then she put 4 of them away. She got rid of them. Okay? She subtracted them from her total. Josie's brother blew up 28 balloons for the party and had enough to put 4 at each table. So he had a total of 28, and then we divided it into 4 groups. Okay? Oh, I think I said it. Okay? Josie had $28 in her savings account. Josie earned $10 helping with chores. Josie spent 6 right away, but she put another 4 in her account. So we start with 28. She earned 10. So we probably added 10. She spent 6, so you're going to have to subtract 6. But then she added another 4. So that might be a little bit trickier, but I think you can get there if you do them one at a time. Okay? 28 minus 10 is going to be 18. And then if we do this, oh, that was plus 10, excuse me. 28 plus 10 is 38. And then we said to subtract 6, which would be 32. And then we do 32 plus 4, which should be 36. Something like that. How much money did she have in her savings account then? Oh, my math isn't working out. What did I do wrong here? Help me out, class. Josie earned $10 helping with chores. She spent 6 right away. But put the other 4. Oh, I thought that said another 4. That's so tricky. Okay, can you ignore this, please? Teachers make mistakes too. She had 28. Now, she earned 10. She spent 6 of it, which means she had 4 left. She's going to put that 4 into her account. Okay? There we go. Now my brain's back on track. Okay, write a story problem for each of the 2 equations below. Solve your own problems. By the way, make sure you guys are connecting these problems with a line. Make sure you do that, okay? And then solve your problems. So you can use the grid paper on the right if you want to. Nothing wrong with doing that, okay? 16 times 8. Well, we could take 10 times 8 and 6 times 8. Okay, we'd have 80 and 48. If you add them together, get 128. Now, I kind of did that by breaking apart my math, which I suggest you do. 16 times 8 is hard to do in your head. You could stack it. You would get the same answer. But you're going to create a problem in here that says 16 times 8. Okay? And you need to list your solution with units. Okay? Maybe it's, my problem might be something like, I had 16 candy bars, and each candy bar had 8 pieces. How many pieces did I have in all? Right? That would be 16 times 8. Now, here you're going to do a 16 divided by 8. If you take 16 and you divide it into 8 pieces, into 8 groups. Each group has 2 in it. Because you remember that 2 times 8 should be the large number. If you multiply the smaller 2 numbers, you should get that number. That's how you can check your answer. Okay? So this might be a problem if you're going to divide something. You might say, I have 16 candy bars and 8 friends. How many candy bars is each friend going to get? 2. Okay? And make sure you write your answer with the units. Mine would be candy bars here and pieces here. Okay? Pause it if you need to so you can catch up. Okay? Because I'm going pretty fast, but feel free to pause whenever you want. Josie's mom bought 9 pizzas. Ooh, I want to go to that party. She will need to cut them in order to have enough pieces for the party. So they haven't been cut yet, so they should just be kind of like a circle, right? She's going to decide how to cut them and how many, right? See problem 2 for more information. Use number sketches or words to show your work on another sheet of paper. So I'm going to go back to problem 2. There are 24 kids at the party. That's major. That's gonna inform us a lot. And we have 9 pizzas. 24 kids, 9 pizzas. So we have to divide these pizzas so that we can feed 24 kids. Oh my goodness, I just said the answer. I said the word divide. So we should be able to take 24 divided by 9 and figure out how many pieces of pizza we can give everybody. Now, 9 does not divide evenly, does it? Or 24 doesn't divide by 9 evenly, because I can divide 9 into single pieces. I can divide 18. I can divide 27. I can divide 36. All of these are numbers, multiples of 9. These are great numbers to divide by 9. 24 is not. Oh, so what are we going to do to make sure that we have something that makes sense? I think we have some options here, and I'm going to draw mine on the back of this one. I could draw 9 circles. Keep in mind you have to feed 24 people. If I split each one in half, I have 18 giant pieces of pizza. If I divide them all in again so that I have 4 pieces of pizza, then I have 36. Well, that's too many. 18 was not enough. 36 is too many. But maybe we want leftovers for more people to have. So maybe your answer is you're going to cut them each into 4 pieces and you'll have 36. Can we cut our pizzas in a weird way? Let's see. I'm going to take my 9 pizzas and I'm going to cut them into thirds so that I have 3 pieces for each. If I have 3 pieces on each pizza and I cut the pizzas 9 times, okay? 9 times 3 is 27. So now I'm closer to 24, but I still have too many. So maybe the best that I can do to make sure that it's fair is I'm going to cut each pizza into 3 slices, which is kind of crazy. That gives everybody way more pizza than they need. 1/3 of a pizza per person? Wow. But that's up to you. Whatever you write, make sure you draw it and give me some sort of rationale for how you would cut 9 pizzas for 24 people. Okay? As always, ask your teacher if you have help. Get clever, guys.